Hello everyone, I am Resection. The paper that I am going to present today is virtual resection planning using Bezier surface interaction in collaborative VR environment. Without further ado, let's get started. Surgical resection is a common treatment against tumor-related cancer. However, it is a challenging intervention due to the complex internal structure, such as vascular tree for each patient. So it requires extensive preoperative planning. Preoperative planning with virtual resection can support surgeons in mental preparation, understand of complex internal structure, define the resection volume, consider the affected vessel, safety margin around the tumor, and more importantly, improve skill and build confidence during the intervention. Preoperative planning is based on a stack of medical volume data representing the image slice of the organ acquired from MRI or CT scanner. While 2D image of the CT or MRI data provide anatomical detail, 3D visualization offer even better overview of the large-scale feature and general configuration. However, most of the systems for surgical planning are based on conventional 2D screen, which could offer the user with limited visualization and interaction opportunity compared to a VR setup. Several studies show that immersive VR could provide a better environment for surgical planning. However, using only a single user VR could also offer some limitation, especially the team collaboration. So collaborative VR allows multiple users to join in the same shared virtual environment, and it has been used for training the communication and collaboration among interprofessional teams. The use of collaborative VR in the context of training medical students or planning together in a surgical intervention could allow them to safely perform in the virtual environment, improve their skills respectively, and discuss the result with the training of with the supervisor directly in the virtual environment. There are three common approaches proposed to define a virtual resection planning. For example, drawing the trace on 2D slide of image data, using deformable Bezier surface, and using deformable cutting plane (DCP). In previous work, we investigate the deformable cutting plane approach in the collaborative VR environment. However, in this work, we explore the use of different interaction approach with the Bezier surface for virtual resection planning. We integrated this technique and enhanced it into the collaborative VR environment. And we conduct a pilot study to assess the usability of the technique in a comparison with the DCP approach from previous work. Well, let's talk about the system implementation. A Bezier surface describes a parametric surface with a set of control points, which can be considered as points of attraction that pull the surface toward them. The advantage of Bezier surface is the major deformation of the void area can be achieved with a few control points rather deforming manually. In addition, the mathematical model of the Bezier surface could guarantee a level of smoothness depending on the chosen degree of the polynomial. So in this work, it's similar to Paloma et al., which choose a third degree in both directions with 16 control points. And for evaluation, to acquire a valid positions and resection surface that should act as the target for the study participant, we ask a general and vascular surgical resident to use our prototype and perform the virtual resection for 4 patient cases. The session was conducted remotely in our collaborative VR environment. So the expert joined in VR from University of Mainz in Germany, while the investigator joined from University of Magdeburg. The expert tests both interaction techniques between the Bezier surface and the deformable cutting plan, and the final configuration of this resection planning was saved. So for pilot user study, we recruit 10 participants. The participants were asked to explore the prototype and perform the virtual resection with both interaction technique. The 4 patient case results from the expert planning were used in this pilot study. So 1 was used in the training, and the other 3 were used for the actual task, for example, case 1, case 2, and case 3. Well, for the result of user performance, the average task completion time for each task were recorded. The average total completion time for DCP took around 148 seconds, while the Bezier surface took around 181 seconds. There was a significant difference of the task completion time on case 2, as you can see in the figures, between both techniques. So it could show that the deformable cutting plan, the DCP approach, was performed faster than the Bezier surface. According to the participant feedback, 3 participants report that they struggle with either the concept or practical application of the Bezier surface to deform the resection surface, though they need more guidance during the training and took more time on the first case. For subjective measure, a standard NASA TLA questionnaire was used to evaluate the task loads. It includes the mental demand, physical demand, temporal demand, performance, effort, and frustration, as you can see in the figure below. The overall score of the rating, it shows that the score of the Bezier surface were higher than the DCP, and there was significant difference on the mental demands and the frustration from the NASA TLX questionnaire. It could show that the DCP was relatively easy to use for those who are not familiar with the Bezier's curve. However, physical demand was relatively similar between both techniques. So in conclusion, we have present a new approach for defining resection surface for virtual resections, making use of the cubic Bezier surface in the collaborative VR environment. The result of the pilot study show in size for both interaction technique. However, the number of participants was relatively small, and the aim of the formative study was to test and collect the feedback for the improvement, since it was the early stage of system development. The Bezier surface has potentially to quickly perform the resection surface, while DCP could provide detailed information, especially the user can deform it in a small area to avoid the affected vascular structure. Our future work aims to conduct an extensive clinical evaluation and also try to transfer to another surgical disciplines. Yeah, well, thank you for your attention.